Our sun, a blazing ball of plasma, a life giver. But have you ever wondered, where did it all begin? Billions of years ago, our sun was just a cloud of gas and dust. This vast, swirling cloud, called a nebula, held the ingredients for a star. Gravity, the architect of the universe, worked its magic. It pulled the gas and dust together, tighter and tighter. The cloud collapsed under its own weight. As the particles collided, they heated up, generating immense energy. At the heart of this chaos, a star was born. The pressure and heat became so intense that hydrogen atoms fused, igniting nuclear fusion. This incredible process released an unimaginable amount of energy, and our sun began to shine. This is the story of our star, a story of cosmic evolution, of birth, life, and eventual death. It's a story that unfolds over billions of years, a timescale that dwarfs human comprehension. How do we know the age of something so ancient, so far away? Scientists have developed ingenious methods to unravel the mysteries of the sun's age. One method involves studying meteorites, remnants of the early solar system. These cosmic time capsules contain radioactive elements that decay at a predictable rate. By measuring the ratio of parent isotopes to daughter isotopes, scientists can calculate their age. These measurements tell us that the sun is approximately 4.6 billion years old. Another method relies on helioseismology, the study of the sun's vibrations. Like listening to the ringing of a bell, scientists analyze the sun's oscillations to understand its internal structure and evolution. These techniques, combined with sophisticated computer models, provide us with a remarkably accurate estimate of the sun's age. They offer a glimpse into the distant past, allowing us to trace the sun's journey through time. Currently, our sun is in its main sequence, a period of relative stability. During this phase, it fuses hydrogen into helium in its core, generating the energy that sustains life on Earth. This process is a delicate balance between gravity's inward pull and the outward pressure of nuclear fusion. The sun's energy output is not constant. It varies slightly over time. These variations, known as solar cycles, are driven by the sun's magnetic field and influence space weather. Understanding these cycles helps us predict solar flares and other events that can impact our technology. The sun's main sequence will last for billions of years, but it's not a static state. As it continues to fuse hydrogen, its core slowly contracts, becoming denser and hotter. This gradual change will eventually have profound consequences for the sun's future. Don't worry, we have billions of years before the next act. But eventually, the sun will exhaust the hydrogen fuel in its core. As this happens, the core will contract further, while its outer layers will expand dramatically. The sun will transform into a red giant, engulfing the orbits of Mercury and Venus. Earth's fate is uncertain. Some models suggest it will be swallowed by the expanding sun, while others propose it may be pushed outward, escaping complete destruction. Regardless, life as we know it will be impossible. The red giant phase is a time of intense stellar activity. The sun will shed its outer layers into space, forming a planetary nebula. These glowing shells of gas and dust will enrich the interstellar medium, seeding the universe with the building blocks of future stars and planets. After its red giant phase, the sun will undergo a dramatic transformation. It will shed its outer layers, leaving behind its hot, dense core. This remnant, called a white dwarf, will be no larger than Earth, but incredibly massive. A white dwarf shines with residual heat, slowly cooling over billions of years. It no longer generates energy through nuclear fusion, but instead radiates its stored heat into space. Eventually, the white dwarf will fade away, becoming a cold, dark object known as a black dwarf. The black dwarf stage is the final chapter in the sun's life cycle. It represents the ultimate fate of many stars in the universe, a testament to the relentless march of time and the impermanence of even the most massive objects. The sun's story is more than just a celestial drama. It's a reminder of our place in the cosmos. Understanding the sun's life cycle helps us appreciate the vastness of time and the interconnectedness of the universe. By studying the sun, we gain insights into the processes that govern stars, galaxies, and the universe. We learn about the origins of the elements that make up our bodies and the planets. We explore the potential for life beyond Earth and the ultimate fate of our own solar system. The sun's story is a story of wonder, beauty, and scientific discovery. It's a story that continues to unfold, inspiring us to explore the mysteries of the cosmos and our place within it. If you enjoyed this journey through the cosmos, don't forget to subscribe to my channel for more fascinating content.